question I received in the homework, and I want to go over it first because I got some 9.3 questions to go over. I had a Zoom that was messed up Tuesday as well. Well, the only thing bad about Zoom is it's not protected by Tri-County Tech. That's why I don't use Zoom. I have used Zoom at home with other people, but I don't want to use Zoom, one, because China owns it, and two, I don't use it because it's not internally secure with Tri-County Tech. So that's why I don't want to use Zoom. I don't mind using it. I just prefer not to use it because of those two reasons. Okay, so the first thing I'm going to do, I'm trying to think of what's the best way. Let's go with the questions first. One question is from 9.2. I mean, what am I talking about? 9.1. One question is from 9.1, and I do want to go over it because it is a test question. And here it is. This is the question, and y'all all seen this, and we did this in class, but we'll do it again because it is a test question. So we got a drawing. We got a bicycle pedal, and that bicycle pedal has a radius of 4.61 inches. I'll show you my writing after I write everything down. Okay, and we've got a smaller pulley at R is equal to 1.01 inches. And it says if the pedals are rotated 180 degrees, that's pi. So I'm going to draw in a pink arrow, and that's equal to 180 degrees or pi. And the bicycle wheel, I'll draw it another color. I'll draw it as a green. That radius is 13.5 inches. Okay, so basically this is what you got. That's what you got. Let's go ahead and draw you a picture. Now, if this angle is 180 degrees, and we've got to find basically this distance. So we got to find the arc length. And length is equal to R times theta. So length is going to equal R, which is 4.61, times theta, which is pi. So the arc length is going to be equal to 4.61 times pi. 14.4827 ... inches. So if this pulley moves 14 inches, then this pulley has to move 14 inches, and it may go 2 or 3 around because it's so small. Okay, now let's talk about this. This is 4 times as big as this, so it might have to go around 4 times. Okay, so that's just thinking. So if that 14 inches right here, it may turn that thing 3 or 4 times. So we've got a length of 14.48 inches. So I'm going to use a different color. I'm going to use this pink. No, not the pink. I've already used pink. Let's use orange. So this guy has got to go around 14.4827. 14.4827 inches. Inches. And we know we got to find the angle. So the angle is going to be the length divided by the r. So theta is equal to the length divided by r, which is equal to, length is 14.4827, 14.4827 divided by 1.01. There, I moved it. Divided by 1.01. And that's going to give me 14.33. That would be in radians, correct? Theta is equal to 14.33 radians, which means it has pi in it. So I'm going to divide that by pi, divided by pi, which is 4.56 pi, or 4.564356 pi. Now, if I wanted to, I'm going to have to multiply that by 180. I'm going to multiply that by 180, and that's going to give me 821 degrees. So I'm going to multiply this. This is over 1. Multiply that by 180 over pi, and that's going to give me 821 degrees, 821.5 ... degrees. I'm sorry, I'm trying to get everything there. Now, we really don't have, we can use both of these numbers because this is pi, this is radians. So we're going to go up here and we're going to do the arc length of the bicycle wheel is equal to 13.5 times 4.56 ... pi. And that should give us our answer of how far the wheel has traveled. So divide by 180. I'm going to go ahead and divide by 180. And that's going to give me that. So I'm going to multiply that by 13.5. Wait a minute. That's times pi, times 4 times pi. Yeah, times pi. Sorry. I'm doing it backwards. I'm sorry. Times pi. There we go. Times 13.5. So that traveled, that wheel has moved 193.58 inches. So I don't know if that's what the question's asking. I think that's what it's asking. And you have to think, this is critical thinking right here. If this pulley goes that distance, if it turns that distance with that rotation, then that distance has to be transferred to this distance. Okay, and that 14.8, whatever it came out to be, that has to turn 2 or 3 times. So that must be a very small, it is. The radius is 1 inch. 1 inch is from your knuckle to knuckle on your index finger. Okay, so that's a very small gear right here. And then you find out the revolutions, which is 4.56. The reason I did the 180, because some questions ask you to change it into degrees. So I got 193.58 and 193.58 to the nearest tenth, 193.6. And you feel good about yourself. So does that help? I hope that helps for whoever sent it. And that's the second one or the third one we've done. So look in your notes and you have 2 or 3 of these that you can work out. Next question. And this is a test question too, because it's out of 9.3. Let's see. Oh yeah, it's a test question. So what do you need to do? Well, you need to remember your special angles. And there are your special angles right there. Let me get the bicycle out. There we go. Well, Hubert, that says 330. Yeah, I know. And that's where you got to use your handy dandy. Remember, everything's based on a 30-degree angle, 45-degree angle, and the 60-degree angle. Everything. So this is 30. This is 45. This is 60. This is 90. This is 180. This is 270. So you just have to figure out the rest of them. Well, this one goes down this way. This one goes down this way. And this one goes down this way. Somebody tell me what 180 plus 30 is.
210.
And what's 180 plus 45?
225.
Good job. Thank you for the interaction. I appreciate that. What is 270 minus 30?
240.
Okay, now what, Hubert? Well, go over here and draw your 30-degree angle here, your 45-degree angle here, your 60-degree here, and then traverse them down here. What is 90 plus 30?
120.
What's 90 plus 40? 5, sorry.
135.
And what's 180 minus 30?
150.
It's a miracle. What is 360 minus 30?
330.
Oh my gosh, look at there. There's that 330. It's a miracle. What is 270 plus 30?
300.
And what is 270 plus 45?
315.
You've just done the unit circle. Congratulations. That's why you have to have these 3 angles. These 3 angles are bricks in the footing of trigonometry, just like the Pythagorean theorem and just like the 6 trigonometric functions. Okay? So 330 is in this quadrant. So let's draw a bigger representation of 330 because it's right here. Everybody see it? I'm going to take my handy dandy highlighter because I like to help y'all out as much as possible. Here is the angle that this homework question is reflecting on. So I'm going to transfer this one to the next page. and we're going to draw a BA graph, and that graph is going to reflect the third quadrant. Now, we all know that the 30-degree angle, has a base of square root of 3, it has an opposite of 1, and a hypotenuse of 2. So that means this is the square root of 2, this is 1, and this is, 3, and this is 2. Now, which side of the triangle is never negative?
The hypotenuse.
So I'm going to take my handy-dandy green highlighter, and I'm going to highlight that 2 because it will always be positive no matter where it is. And this square root of 3, it's in the positive x direction because this is the first quadrant. So it's positive also. So I'm going to highlight it, positive. But what about that 1?
It's going to be negative.
The 1 is going to be negative. So we're going to color it pink. And we're going to put a negative there. And now you can fill out your chart. So let's fill it out. Sine, cosine, tangent, cotangent, secant, cosecant. Oscar had a hunk of apple. We know this is the opposite. We know this is the adjacent. And we know this is the hypotenuse. Oscar had, okay, -1 over 2, -1/2. A hunk, square root of 3 over 2. Of apple, 1 over square root of 3, which is square root of 3 over 3, which is negative. Now, that was 1 over the square root of 3. So now I'm going to flip it and get square root of 3 right here, negative square root of 3. 2 over the square root of 3, which is 2 square root of 3 over 3. 2 square root of 3 over 3. And then the cosecant is going to be -2. That should be your answers. So let's go back and look, unless I've done something crazy. Sine is equal to -1/2. Cosine is equal to square root of 3 over 2. Square root of 3, right arrow, divided by 2. The secant is equal to 2 square root of 3. 2 square root of 3, shift to the right, divided by, oh, horse pookie. Let me do the little do-jigger down here. 2 square root of 3 divided by 3. And let's see if we feel good about ourselves. Yes, we do. That's a test question. It's also a standardized test question. 90% of trigonometry is, do you know where you are? What in the heck are you talking about, Hubert? When you are talking about trigonometry, 90% of the question depends on, do you know what? Where you are on the unit circle. If you don't have a clue where you are on the unit circle, then you're going to have a hard time. And you've got to learn I didn't say memorize, I said learn. You've got to learn that unit circle. Now, hopefully that helps with your question. But I wouldn't mind doing another one because I know some of y'all suck at this. And you can volunteer if you have trouble with it or forgotten it or whatever the case may be. But some people, when they see this question right here, they forget. And nobody says a word. Appreciate it. Let's see. This may be another one. Let's see if this is another one. Yep. All right, I'm going to let y'all do that one. And if you can't do it, we'll just write it up as being a failure in life. And nothing. Not a single reaction. Y'all suck. Y'all know that?
I laughed. I was just on mute.
What?
I laughed. I was just on mute.
Oh, I appreciate it. I was just looking for any kind of reaction. When, anything is better than zero. I know one thing. Somebody's blowing up my daggum email. So y'all finished? No, I'm letting y'all work. See, y'all talk more when I don't talk. So I'm just not going to talk anymore. How about that? Okay. Since y'all not going to talk to me and I don't know how far you've gotten, I'm going to start over. All right, this one says 315 degrees. Well, from the unit circle that we just did. Oops, sorry. 315 degrees is right here. And it belongs to Mr. 45. So again, we're going to draw a BA third quadrant. And there is my Mr. 315. And that means he belongs to Mr. 45. So that's a 1, 2, 1. We know that this guy is, we know that the hypotenuse is positive. And we know the adjacent is positive because it's going in this direction and this is the first quadrant.
Wait, isn't it root 2?
I'm sorry, what?
Isn't it the root 2? You have 2 as the hypotenuse, not.
Oh, yeah, I'm sorry. Yes. Thank you.
Yes, sir.
I just want to make sure y'all were awake. Thank you. And the negative is right there. So we put a negative there. Sine, cosine, tangent, cotangent, secant, cosecant. Oscar had -1 over the square root of 2 which is equal to negative square root of 2 over 2. A hunk 1 over the square root of 2, which is equal to the square root of 2 over 2. Of apple, negative 1 over 1, which is negative 1. And the reciprocal of negative 1 over 1 is negative 1 over 1, so the cotangent is equal to negative 1. The reciprocal of 1 over the square root of 2 is square root of 2. And the reciprocal of, 1 minute, hold on. All students take calculus. The cosine and the secant should be positive. I just want to make sure. Negative, okay, there we go, positive. Okay, everything's negative. I was just wanting to make sure. Okay. Negative square root of 2. Now let's check and see if we know what we're doing. So negative square root of 2 over 2. Cosine is square root of 2 over 2. Square root of 2 divided by right arrow divided by 2. Negative 1, negative 1. And the secant is the square root of 2. And I guarantee you there's somebody in here going, I didn't know it was that easy. It is. It's real simple if you know the special angles. Don't you feel good about yourself?
I feel so good right now.
There you go. I guarantee you there's somebody going, wow, I never knew that the unit circle was that easy. It is easy. All you got to know is these special angles. You already know 0 and 2 pi. You already know that this is 0 and 360. And that's 90, and that's 180, and that's 270. Now, if you need to change it, you know these are degrees, so you got to multiply pi over 180, and then you can simplify each one of them. So let's see what the next homework question says. Y'all don't mind, I'm going to delete these two so I don't redo them. 9.337/18. Rewrite sine of 65 degrees in terms of the cofunction. Now, we haven't covered this yet, so I'm going to stop right here. We're going to go back to the slides, and we're going to talk about that. Now, I think this is where we were the other day. Oh, shoot. I think this is where we were the other day when we were rudely interrupted by the team's malfunction. And of course, I think I went over this and we just talked about that just now. So that's that. And then find the 6 for 60, and we talked about that right here. There are the here's your 60 degree right here. There's your 60 degree angle right here. So you find the 6 trigonometric functions of that. This is the opposite, this is the hypotenuse, and this is the adjacent. So you can find those 6, you know. I'm not going to go over that because I think y'all can do that. So, and there they are. There's a 60 degree angle. So Oscar had, that would be square root of 3 over 2. A hunk would be 1 over 2 of apple, which would be 2 over 1. No, I'm sorry. Oscar had a hump of apple. That would be 2. Wait a minute. Oscar had a hump of, oh, there it is. Square root of 3 over 1. I'm sorry. Square root of 3 over 1. And then flip them over. And I'm not going to go over that. You can flip. I think y'all can flip 1 over 2 to 2. I think y'all can do that. And square root of 3 over 1 would be square root of 3 over 3. And that's it. So, all right, here are the cofunction identities. So you need to write them down. The sine of A is equal to A over C. Oscar had, opposite, Oscar had, which is equal to the cosine of B. Okay, now this is where the cofunction is where the little man is standing. Okay, let me get off of this right now. All right, if the little man, let me go to my handy dandy because I don't want to confuse you. All right, and the slides have a tendency to confuse students. So we're going to draw there's a triangle and here's a triangle. And we're going to call this Oscar. I mean, that's Oscar, that's had, and that's adjacent. Adjacent, oh, I'm not going to do that yet. And that is when the little man is standing right there. His foot is always on the adjacent and the hypotenuse. It's always on the adjacent, and he's always looking to the opposite. That's when theta is down here. The cofunction is when theta is not down there, but it's up here. Theta, meaning that the little man is up here now, and his foot is on the adjacent and the what? The hypotenuse. And now this is the opposite. So let's talk about this. The sine, I'm going to use pink. I'm going to use pink on this one. The sine of this theta is equal to Oscar had. The sine of this guy, or the cosine of this guy, Oscar had a what? A hump. So the sine of this theta is equal to what? The cosine of this theta, which is equal to A over H. That's what they're saying. Now, I don't want to confuse anybody, but I just tell students, if you see the theta down here, then you put your little man down here, and you know this is the hypotenuse and this is adjacent. If theta is up here, then you put your little man up here, and his foot is on the hypotenuse and the adjacent. That, to me, is the best way to show students the cofunction. Okay? Now, I'm not going to show you these slides on the cofunction because I think they confuse students. But when we get to an example, I'll show you how's the best way to use it. So let's go back to the slides, and I'm going to just skip this one. And are they going to give me an example? Okay. Express, write each expression in terms of its cofunction. All right, this one we really can't do. We have to do it by the book because we don't have a special angle for this one. All right, so the cosine of 52 degrees is equal to the sine of 90 minus 52 degrees. okay? Because we don't know, we have to actually type that in a calculator. So if it's not a special angle, you have to follow the rules. Let me go back. Hold on a second. Where's my backspace? I think it's those right there, but I'm just gonna, yeah. Those right here. So I'm gonna give you a second to write those down if you want to. I'm not gonna ask a lot of cofunction. I will ask you to put the man on a different angle. I will ask you to do that, but I'm not gonna ask you too many of these on the test, but you need to go ahead and write them down. This is not detrimental to you making an A in trig, but you may need them later on. Finish writing them down, please. Okay. So if you're given an angle and they say the cofunction, then you subtract it because, and that comes from this right here. I'll show you where this comes from. And I don't know how many of you have had trig or not, but I'll show you right quick. If you have an angle, how many degrees make up a triangle? I'm asking y'all.
180.
Okay. 180 degrees makes up a triangle. Okay? If 180 degrees makes up a triangle, and you're already given that this is a right triangle, that's 90 degrees. So the remainder 90 degrees has to be divided up between this angle and this angle. So that's where you get the 90 minus whatever. Okay? This right here has got to be equal to 90 degrees with this one. So if this was angle A and angle B, A plus B has to equal 90 degrees because this is 90 and 90 plus 90 is 180. So that's where they come up with that 90 minus the angle. Okay? So that's where they come up with that. Right here, 90 minus the angle, 90 minus the angle. So if I want to find, if I got the sine of 52 degrees, then I'll put cosine of 90 minus 52 degrees. That's the way it works, but it's, again, it's not detrimental. It's not a test question, I don't think. I don't think I put that on the test, but we'll keep going. And these are also, if you're using radians, 90 is pi over 2. So that's, you know, and you can also say, well, sine, cosine, cosecant, secant, and then, of course, cotangent and tangent, because those are cofunctions. The sine and the cosine, the cosecant and the secant. So I don't want to insult your intelligence by going into that more, but I think most of you can see that the cofunctions are the ones with the CO in front of it. Okay? Has everybody got these? I hope. So the cosine will be the sine of 90 minus 52/16. Tangent would be cotangent of pi over 2 minus pi over 6. And the secant of 1 would be the cosecant of pi over 2 minus 1. Because that's not 1 degree, that's just 1. So that would be taken from pi. I mean, from radians. Again, not a big deal. Reference angle. Reference angle is the other angle. In a complementary, we already talked about this. In a complementary, it would be minus 90. In a 180, a supplementary, it'd be minus 180, minus from 180 to 70 and 360. And we discussed that when we did this. Okay, what they're leading you up to, they're fixing to get you to do the unit circle is what they're fixing to get you to do. Okay, what did I do? Well, I went around and I did 90 plus 30, 90 plus 45, 90 plus 60, or 180 minus 30, 180 minus 45, and so on. So those are your reference angles. All this will tie in. It will. Don't worry. Don't get nervous on me. Find the reference angle to 218 degrees. Well, that's simple. Now they got to. They're making sure 218 degrees. Let's turn back one. Remember, in academia, the left-handed angle is where you turn from. In the real world, it's the other way around. But left-handed angle this way. Left-handed angle. So 218 degrees would be left-handed angle, 218 degrees. So 218 degrees, well, there's 180. And 218 would be right in here somewhere. 218 degrees. So if you want to find your reference angle, which is this angle right here, that would be 218 subtracted from 360, and that would be your reference angle. So 10 minus 8 is 2, 5 minus 1 is 4, and 3 minus 2 is 1. So your reference angle is 142 degrees, and it would have a minus sign because it's turning the opposite way you're supposed to. And in academia, that would be negative. In the real world, this would be positive, and this would be negative. So 142 degrees would be that one. Oh, they're wanting it with 180. I'm sorry. Okay, well, 180. I thought they wanted it with. Okay, well, you could do that. They should. They don't really give you specification here. I guess they're wanting the closest quadrangle. Okay, so my bad. I really. No. Okay, so let me use another color. And if you wanted it with this angle right here, that's orange. Okay, that angle right there is 38 degrees. And you got that because 180 subtracted from 218 is 38. So I read the question wrong. I thought they wanted the reference angle to 360. Now, 1387. 1387, we talked about this in the first unit or the first couple of sections. 1387 is going around and around and around. So 1387, first of all, I'm going to divide 1387 by 360. So 1387 divided by 360. So I know I got 1387 divided by 360. So that gives me almost 4 revolutions. So that gives me 3 revolutions, 3 solid revolutions. So 3 times 360 is equal to 1080. So I'm going to subtract 1080 from 1387. 1387 minus 1080. And that is my degrees. 307 degrees. So 307 degrees, that's 270 plus a little bit more. Okay, so I'm just going to put it right in here, and I'm going to say 300, oops, sorry. 307 degrees. Now I'm going to give you both angles. I'm going to give you in reference to the 270. We'll do that in orange. And then I'll give you the reference angle to 360. So of course 360 would be 360 minus 307. And that would be a 10, 3, 5, be 53 degrees. So the pink is negative 53 degrees. If you wanted to see how far it was past 270, then you would take 307 and minus 270, and that would give you 7 and 10 be 30, 37 degrees, I think. Yeah. And this would be 37 degrees. So it all depends on if they want it from the quadrangle or from 360. Let's see what they want. $53 degrees. They wanted it from 360. Okay. But you ought to be able to do both. You ought to be able to go, you know, okay, it's 37 degrees from here and 53 degrees from here. And technically you could do it 90 plus 37 to be 127 degrees from here. So you ought to be able to work your way around the unit circle. And 5 pi over 6. Well, first of all, if you don't know what 5 pi over 6 is, you change it to something that you know. So what do you mean? Hold on a second. Shoot. Okay, 5 pi over 6. This is what you do if you ever get confused. 5 pi over 6. I have no idea what 5 pi over 6 is. Well, then you change it to 180 over pi. And of course, the pi's cancel. And 6 will go into 180 30 times, and 30 times 50, 30 times 5 is 150. So you know that 5 pi over 6 is 150. So let's go with 150 degrees. Be somewhere right in there. And you know automatically that this reference angle here is 30 degrees. Well, what is 30 degrees as far as 5 pi over 6? Well, you could also do this like this. This is 0. This is pi over 2. And this is pi. Well, pi minus pi of 5 power of 6. Pi minus, that's a 1, minus 5 power of 6. Well, I got to get a common denominator of 6. 1 will go into 6 times. That'll be 6 pi over 6 minus 5 pi over 6 is equal to pi over 6. So your answer is either pi over 6 or 30 degrees. But either way you do it, you're going to get the same answer. You just got to put it in terms of pi. Like right now, 30 degrees right here. Okay, well, I got to change that into pi. So I go over here and I say 30 degrees over 1. I need degrees on the bottom. I need pi on top. The degrees cancel. Where's my red pen? The degrees cancel, and it leaves you with pi. The zeros cancel, and that leaves you with 3 will go into 3 one time. 3 will go in there 6 times, pi over 6. So what am I trying to tell you? As long as you know where you are, you can lick it. As long as you know where you are, whether it be with pi or whether it be with degrees. But make sure you put it back in terms of pi because that's what they're going to ask you. So the answer here is going to be pi over 6. There it is. Now, these type problems I will ask you on a test. Reference angles are important. So make sure you know how to do reference angles. Next, wait a minute, let me check the time before y'all start convulsing. Okay. Next, somebody's trying to take control of my board. Find the values of the trigonometric functions for 210. Well, what for 210 degrees, this is exactly what I was talking, it's like the question. 210 degrees, I have no idea what to do. Well, first of all, let me draw this. 210 degrees is going to be more than 180. So I got it right here somewhere. So I got to find out using my reference angle. So 210 degrees minus 30. Okay, or I'm sorry, 210 degrees minus 80, 180. 210 degrees minus 180 is equal to 30 degrees. So we know we've got 30-degree angle, which is a special angle, which is square root of 3, 1, and 2. Now somebody tell me what the adjacent is in the third quadrant. Is it positive or negative? That means I want y'all to interact with me. It's not rhetorical.
They're both negative.
It's negative. What is the opposite? It's negative. So therefore, we always know that the hypotenuse is positive. So we know why all students take calculus. All students take. So that means the tangent and the cotangent are both what? Positive. The rest are negative. All students take calculus. So let's see what we got. Sine, Oscar, pad, negative 1 over 2. Cosine, A, hunk, negative square root of 3 over 2. Of apple. Of is going to be negative 1 over negative square root of 3, which is positive, which is square root of 3 over 3. And of course, you could flip them over. The cosecant is going to be negative 2. The I have to do this secant. I'm not used to doing them across from each other. The secant is equal to 2 square root of 3 over 3, and it would be negative 2 square root of 3 over 3. And the cotangent would be 3 square root of 3 over 3, which is square root of 3. I hope I'm knocking some cobwebs loose. I hope people are saying, okay, this ain't that bad. I remember this, or hopefully you haven't seen it and right now y'all aren't telling me anything. So I don't know if I'm, throwing darts in the dark or what. I don't know. Y'all don't, squeaky door gets the grease. I'm assuming that everybody's okay because nobody's saying anything. And still nobody says anything. Y'all do this to all your classes? Good. Good. Thank you. 3 people. Thank you. I appreciate that. Slow and steady, kind of. Okay. How long has it been, Mr. Parrish, since you had trig? What he said. Okay. So with that, hopefully we get the answers. Let's see what our answers. Okay, for the sine, I got -1/2. For the cosine, I got negative square root of 3 over 2. For the tangent, I got square root of 3 over 3. Ding! We are special. Okay? So that's how you do that one. Is that a test question? Yes, that's a test question. Anything having to do with the reference angle is a test question. Oops. There we go. And here's where they're talking about the reference to 360. That's what I thought they were talking about. So, all right, let's do these two. Find the exact value, that means with a radical, of each expression. -240. Now remember, when they say -240, that means the way the real world turns it, to the right. -240. Well, there's 180. 240 be it here somewhere. -240. So let's figure out what this pink angle is right here. So that's going to be 360 minus 240. Well, 360 minus 240, 360 minus 240, dang old 20, dang old 120. Well, what is 120? 120 is your 60-degree angle. So your special angle is 60 degrees. Which is, oh, I should have drawn it bigger. Square root of 3, 2, and 1. And your adjacent is negative. Your hypotenuse is always positive, and your opposite is positive because it's in a positive y direction. So they want to know the what? They want to know the cosine. The cosine is, Oscar had a hunk, be -1/2. Cosine of -240 is equal to -1/2. So let's see what they get. It's a miracle. Now, the tangent of 265, well, hell, we don't know what 265 is. Tangent of 265. Well, I'm sorry, that wasn't, is that 265? 675. Okay, my medicine's wearing off. Sorry, I'm just making up numbers now. 675. Well, I'm going to divide that by 360. I know I can get one revolution out of it. So 360 and 360 is 720. So I'm not going to get another revolution. So I'm going to do 675 minus 360. That'll be a 5 there and 315. So that's a positive 315. And that's going to leave us with, that's a 45-degree angle. 1 square root of 2. And this is negative, and this is positive, and they want to know the tan. Oscar had a hunk of apple. -1 over 1, which is -1. And -1. So these guys are not that difficult. You just got to learn how to find the reference angle. I can't believe they haven't started the unit circle yet. Use a reference angle to find sine and cosine for the given function. Theta is equal to 150 degrees. Well, that's pretty simple. If theta is equal to 150 degrees, then that means, what is this angle right here in pink? Oh, I'm sorry. What is this angle right here?
30.
30 degrees. So you got your 30-degree special angle, which is square root of 3, 1, and 2. And which one's negative? The negative square root of 3. So all students, so sine and the cosecant are positive, but they only want the sine, cosine, and tangent. So sine, Oscar had a hunk of apple. Cosine, tangent. Oscar, 1, 2, a hunk, negative square root of 3 over 2, of apple. So 1 over the square root, which will be negative square root of 3 over 3. And there's your 3 answers. First one is 1/2. The second one is negative square root of 3 over 2. And the tangent should be, oh, they don't want it. Okay, they don't want the tangent. All right, you do 225. And this will be our last one. You do 225. So that would be the 45-degree angle, would it not? 45 degrees plus 180, yep. So that'd be a -1, a -1, and a square root of 2. And they want to know the sine and the cosine. Yeah, they're getting you ready for the unit circle. That's why they're asking you for the sine and the cosine. So here we go. Oscar had a hunk. Oscar would be -1 over square root of 2 and -1 over the square root of 2, which is equal to the square root of 2 over 2 and negative square root of 2 over 2. So they're going to be the same answer. And y'all feel good about yourselves. How far are we to the unit circle? They're teaching you to use your calculator there. We'll go over that, but I'm not worried about that. Okay, they're not going to get to the unit circle, I don't believe. Nope. Okay, so we've covered about 3/4 of 9.3. So you should be able to work on some more homework and send some more homework problems. We were supposed to get through 9.3 Tuesday or whenever y'all came last, but that didn't work out at all. So let me close this out. Let me shut down the presentation in the recorder, and let's see who's here today. Let's see, home, attendance tracker, and Tri-County's website's not working.